I use cout, and then I put please type number. So then this would be like your number that you wanted to put to a power. Right here.
So first one, yeah.
And so it would store it, and then afterwards I had please type in a number that would be, yeah, how many times it'd be rooted, and then I stored that in there. And then I put the total, and I made the total equal n1 to the power of whatever n2 is going to be. And then afterwards, I was going to type in basically n.
Yes, just print out total, just without any print statement, just print out total.
Oh, just print out total? Okay.
Yep, and let's check something.
Okay, and then run it. If it can run. Okay. Okay, so we can do.
We can't see your output window. Instead of sharing Visual Studio, can you share your screen so that we can also see the output thing, because it is.
Oh, share the full screen. Okay.
Yeah.
Hold on.
Where did she find the scene? Scene is basically Sarah. So scene is used to ask the user for some input. So cout and scene come from the IOStream package.
I'm just looking at the, okay, so 8 and 3 are the numbers. Okay. Oh, no, sorry.
The comment terminal there. Yep.
Okay, so then 8.
Yep.
And then 3.
Yep. Now what's going on?
It seems like they added.
They did not add it, but you are quite close on that actually. Okay, so in C++, this operator, the arrow operator, is not raising the power operator, right? This is, so let's see. Have you ever taken any digital logic course before?
No, I only know like the basics.
Basics, right? So in basics digital logic courses, you remember those 4 gates: AND gates, OR gates, NOT gates. Have you heard about those?
Yes.
Okay, did you hear about the XOR gate or the XOR gate?
No.
Okay, so this is essentially performing the XOR operation on your input. So it is a bitwise operation that is, so in an XOR gate, essentially, so we know how AND and OR works, right? If both of them are 1, the output is 1, or in case of OR, if either one of them is 1, then we get an output of 1, right? And NOT makes 1 into a 0, 0 into a 1. Those are the basic things. So in XOR gates, what they do is essentially we have an output of 1 if and only if only one of them is 1. Right. So let me just type this out in the chat. 0, 0 becomes a 0. 0, 1 becomes a 1. 1, 0 becomes a 1 as well. And 1, 1 becomes a 0. So this is essentially how a XOR gate works. So this particular operator is the XOR operator in C++. It is not raising to the power of something. So if you want a single line answer to raising to the power of something, you need to use a library called math or CMath, and that has a function called POW that can be used to find the power of something raised to another something. Now, given that lecture aside, let's say in short, we do not have an operator that raises something to something else. Now, if we don't have that, what can we do to find out n1 to the power of n2?
Multiply n1 as many times as n2.
Yep. Type it out then. Let's see.
Okay. So it wouldn't be this. So it would be.
So I would say initialize total with 1, because we need to multiply, so we can't have it as 0. And then in the next line, have your loop.
Okay. Oh, okay. Could I use, okay, so
you'll be using the total variable as a temporary variable, and each iteration you would be basically multiplying the number n1 until, so basically you will be multiplying n1 again and again n2 times.
oh, okay.
While it's a condition.
So while, and then n2.
Let's see, let's go with that for now.
And then
Total.
n1 has to be in here.
N1 has to be in here, perfect. So total.
Oh, total
equals total times, and we are only going to multiply n1 again and again n2 times.
Times
n1.
n1.
Yep, there you go. Now, basically total would have this particular multiple. Now, this code would still not work because we need to do one more thing. While n2 is fine, but we also need to decrement n2 after each iteration. Otherwise, 8 to the power of 3, n2 will always be 3, and it would keep on looping forever, won't it? We need to make sure that n2 becomes 0 at some point so that we can break out of this. Yes, n2 equals to n2 minus 1. We need to save it back, decrement it, and then save it back to n2.
So like that?
Yep. So at each iteration, it is multiplying and keeping track of the current product. And at each iteration, it is decrementing n2 and using it as a counter. Right?
Oh, okay.
So n2 becomes 3, then you multiply, then it becomes 2, then you multiply 8 again, then it becomes 1, you multiply 8 again, then it becomes 0 and you exit out.
Nice.
Okay, run this code now with 8 and 3.
Run this. Okay.
8, let's go with 8.
So 8 and 3.
There you go.
Yay!
So internally, this is what your computer does. When you call that particular function to find the power of something, it uses this sort of a loop to figure out the power of that thing. And yes, so Sailesh, yes, 0, when n2 becomes 0, it is false. So that is a good question from Sailesh. So now tell me, why does your when does your while loop break out or stop looping? Yeah.
Oh, sorry, say that again.
When does your while loop stop looping?
When it's 0. When it's 0, right?
When it's 0, perfect. Can we do one thing? Can you add one more statement inside your while loop after n2 equals to n2 minus 1? Type in cout n2 and endl.
Wait, sorry, say that again.
n2, no, you don't need to have any text. Just n2, the value of n2, and then endl.
Oh, okay.
So that we can visualize how it works. Perfect. Now if we run this, we can see each value of n2 as it goes down.
Okay.
Right, so run this again. Do it with 8 and 3 again, I guess.
And then 8 and 3.
See, now n2 goes to 2, then it becomes 1, then it becomes 0. And then the moment it became 0, it broke out of that loop and it gives you the output of total. That is 512.
Nice.
Perfect. Does everyone understand this code? Any questions? Are you still able to do a negative number? Very good question. So, Ria, can we do a negative number? So this question now comes in two variants. Can n1 be negative? So can 8 be minus 8? And secondly, can n2 be negative? So let's start with n1. So Ria, run this code again. Remove that internal cout statement.
Okay.
remove, close it.
Oh.
Remove that internal cout statement that you just, the while loop cout, yes. Just adds to confusion. Okay, now run this again with -8 and 3.
So -8 and +3?
Yep.
Okay.
So
guys,
would this work or not? No, not you. Guys, would this work or not? Yes, no. Yes, -8, Bria, and then +3. It still works with a negative number, right? So basically we are doing -8 times -8 times -8, right? So essentially 3 becomes 2, becomes 1, becomes 0, but we are multiplying -8 3 times with itself to get -512. So this is correct. Now, Bria, tell me, would this work with 8 and -3?
No.
Yes.
Oh, hold up. There. No, it wouldn't, because it would just continuously going on forever because of this.
Because -3 becomes -4, becomes -5, and so on, right? So it would never reach 0, and since it would never reach 0, this would be an infinite loop at that, right? Very good. Okay, so in that case, what do we need to do? Because something raised to the power of negative something is basically asking for the root of that value, right? So 2 to the power of -3 is the cube root of 2. So this code does not work with roots or cube roots or any root, square root, or things like that. So in this case, we would be required to check if n2 is a positive number or not. If not, then it won't work. Does that make sense? Perfect.
Yeah.
Now, what happens if we raise a number to the power of 0? What is the output of that operation?
It would just be nothing, right?
No. Something x, any number n to the power of 0 is going to be 1.
Oh, okay. Yeah.
Right. So in that situation, if in your code right now, without making any changes, if I give it 0, would it work?
No.
Yes.
Oh, wait.
Check it carefully.
Yes, it would work. Because the total's 1.
Yep. So even if we give it a 0, this works. Now, if we, as Sailesh asks, if we give a decimal value, it will not work, right? N2 cannot be a decimal value. N2 has to be a positive integer. Because we are subtracting it by 1 each time, we cannot do something as something raised to the power of 4.22. Right, so that is one other thing. Okay, I was thinking if negative, but
Professor.
Yes.
I think it will, when you give an integer, it will round, right?
Yes, it will truncate it off, not round exactly. It will truncate it off to the integer
only.
So even if it is 4.9, it would still truncate it off to 4. Round would mean that 4.9 would still become 5. So it still works kinda, yes. An approximate power algorithm, yes, sure, James. It still works. Okay. Any other questions about this?
Actually, yeah.
Yes.
Could you use a if statement for a positive and a negative number, so it switches between the n2 equals n2 minus 1 and n2 equals n2 plus 1? So then you could also put a negative number in n2 and a positive number, so it flips back and forth.
See, remember that a negative number in n2 means a different thing. And if you have those two separate blocks of code, then yes, sure. But remember that, okay, so what would be the code for, I'll type it in the chat window.